Hello everybody! Today you will learn how orientation of retroreflective sheeting affects nighttime appearance of traffic signs and how to avoid being tricked by unscrupulous manufacturer. Unlike glass beads, microprismatic retroreflective sheeting is sensitive to its orientation. It can be easily observed even under ambient light, and of course you will see a difference in retroreflection of prismatic pieces with different orientation. At narrow entrance angle, you won't see a big difference until I make the entrance angle wider. The wider entrance angle, the bigger difference in retroreflection. This effect is caused by lack of symmetry in optical elements used in microprismatic sheeting. Take a look at how consistent the retroreflection of spherical elements no matter how I rotate and position it, and how a retroreflection of corner cube prism varies when I change its orientation. At a certain point, retroreflection effect disappears. We can also observe this phenomenon by performing measurements of coefficient of retroreflection at different orientation angles for two types of retroreflective materials. I've chosen 45 degrees step for orientation angle, but you can perform your own measurements at 30 or even 15 degrees step to get more precise data. Check it out. At the bottom, you see how beaded sheeting performs at different combinations of observation, entrance, and orientation angles. Look at this smooth performance. By the way, it's not engineering grade, it's high intensity grade beaded sheeting. So you actually see the maximum retroreflection performance we can squeeze out of spherical optical elements. And on top, we have one of microprismatic products available on market. It utilizes corner cube prisms, this kind of prisms. At small and average entrance angles, it performs 3, 4, 5 times better than beaded product. However, when entrance angle grows, microprismatic product becomes less effective and performs the same or even worse than beaded product, especially at some particular orientation angles. What does it mean for a driver? It means that if traffic sign manufacturer uses multiple pieces of sheeting with different orientation in order to minimize the waste. Drivers in some cases may have issues with observing and reading the traffic sign or some areas of traffic sign. It doesn't make prismatic products bad. It just makes the design and application process more complicated comparing to beaded materials. What retroreflective materials manufacturers can do about it? There are two main options. First one is do nothing about the product itself and set up rules for design, application, installation, and ignore those specific cases where their product doesn't perform. You can call these rules the requirements, the recommendations, tips and tricks, it doesn't matter. Of course, this approach increases the waste of retroreflective material during traffic sign production. But at the end, those manufacturers don't pay for this waste. You do, right? If you pay taxes, it means you pay for traffic signs on the road, including production waste. And so these materials that require specific orientation are called rotationally sensitive. Second option is to do tiling. Tiling is creating alternating areas of prisms with different orientations. These areas may look like stripes or squares of different sizes and positions, and it's not a trivial task. Those manufacturers who perform tiling on their product usually have fewer or no limitations for traffic signs manufacturing processes. On the other hand, tiling has downside because it averages the performance of material. It's a very simple concept. If you want to increase the retroreflection performance at certain orientation angle, you will have to decrease retroreflection performance at another orientation angle. That's simple. Performance of some microprismatic materials with tiling is so uniform that you can use them without any limitations on orientation. The performance of separate elements will be the same. There is a methodology described in AASHTO on how to define if material is rotationally sensitive or rotationally insensitive. So it's not only manufacturer's opinion on his product. Let's summarize. There are rotationally sensitive and rotationally insensitive microprismatic materials available on market. Main expected advantage of rotationally insensitive material are lower waste and higher minimal performance. Main expected disadvantage is lower maximum performance. Now you've got basic information about one of many retroreflective sheeting features. I didn't give you my personal opinion on this feature, which I have. I shared only facts. I respect your right to make conclusions yourself. At this stage, I want to ask you to do me a favor. Please be critical. Always be critical to any information you get from manufacturers, from so-called experts, from your friends or business partners, from me. Always perform fact check and use basic logic. Otherwise, you can be tricked. I will show you right now a video about rotational insensitivity, and after this video we will do a step-by-step fact check together. Okay? Here we go.
Driver safety is our ultimate goal. It's why we design sheeting that we feel puts driver experience and safety first. We fabricated a sign using two different ASTM D4956 Type 11 sheeting materials. On the left, 3M diamond gray DG cubed sheeting copy was fabricated at 0 and 90 degrees orientation. On the right, competitive Type 11 reflective sheeting was cut at multiple orientations per their sign fabricator recommendations. It was then mounted at an actual roundabout. A mid-size SUV traveled through the roundabout, with cameras positioned to give a driver's eye view, to capture the difference in reflective performance when illuminated only by the vehicle headlights. In multiple driving scenarios, the application method affects visibility and performance. We believe signs that are uniform in appearance best convey messages to drivers. Others would have you believe this can be achieved by making compromises in the sign fabrication process, but we've chosen to follow a different path. Contact 3M for a smarter approach to road safety.
You can breathe normally. What do you think and what do you feel about this video? Let's start analysis.
Driver safety is our ultimate goal.
No. If driver safety was your ultimate goal, you wouldn't be driving with high beam on and dazzle other drivers. Always pay attention to difference between visual and verbal information. That's important.
It's why we design sheeting that we feel puts driver experience and safety first.
There's no useful information in voiceover, but now in addition to interior, we have exterior appearance of vehicle and we are able to identify it. It's Acura RDX 2013-2015 year of manufacturing. Why would we need to know what vehicle was used? We will calculate angles for road scenarios showed so you could check retroreflective performance of both materials in your local lab instead of traveling to sign location and experimenting with driver's safety.
We fabricated a sign using two different ASTM D4956 Type 11 sheeting materials. On the left, 3M diamond gray DG cubed sheeting copy was fabricated at 0 and 90 degrees orientation. On the right, competitive Type 11 reflective sheeting was cut at multiple orientations per their sign fabricator recommendations.
And again, there is a difference between verbal and visual information. VoiceOver tells us that 0 and 90 degrees orientation was used for 3M sheeting.
Was fabricated at 0 and 90 degrees orientation.
Text in video says 0 or 90 degrees, and animation clearly shows again 0 and 90 degrees orientation. In addition to that, video content doesn't provide any kind of warranty. There is a product bulletin for that. We will go to 3M website and search DigiCube sheeting. So section safety, traffic and safety, 4000 series, product bulletin. Here in product bulletin dated January 2020, we would need section about orientation. Here it is. When high entrance angle performance is required for a given sign, sign should have the sheeting positioned at the 0 orientation. That's nice. Unless sign location calls for extra wide entrance angularity, it can be fabricated in a way that most efficiently utilizes the reflective sheeting. Problem. First, I didn't find anything about 90 degrees orientation. Second, there are no requirements for orientation until entrance angle is wider than 50 degrees. I've been able to find 3M 4090 series bulletin dated March 2006 on their website, and it contains basically the same information except one note. In cases where panels, stripes and tags are placed on the same surface, it's recommended they be placed in the same orientation. So obviously statements in this part of video are lie, because we didn't find anything about 90 degrees orientation, but maybe we have a case with 50 degrees or wider entrance angle. That would explain at least 0 degrees orientation, right? We have to identify now the location of the sign. What do we know so far? This roundabout is located somewhere where 3M can experiment with traffic signs and dazzle drivers with impunity, right? So I would expect it to be close to 3M headquarters, and the first assumption is St. Paul, of course. What else? We know that Jamaica Avenue is somewhere around, and we also see County Route 14 sign and State Highway 5 sign. Let's find information about State Highway 5. State Highway 5, Minnesota. Do I pronounce it the right way? Minnesota? In a history section, the road is known as 34th Street between Jamaica Avenue and Highway 120, and Stillwater Boulevard between Jamaica Avenue and Highway 36. And this intersection looks like the one from the video. Here we go. This is the roundabout, and the traffic sign looks the same, Jamaica Avenue. Right? Okay. We've got location, and now we have to identify car position. So on video we see that this small sign with numerous reflectors is in between steel posts of our Jamaica Avenue sign. So we have to find a position from where this sign could be seen in between these two posts. No, it's further. Okay, it's somewhere here. Right. Now we will have to understand where are we right now. We will use some markers like this edge of the roof. We see it in the same direction with this post. So we go to map and draw a line. And then we would need one more line. That would be this sign and this small post with numerous retroreflectors. So we will draw two lines and we will understand where are we on map. And we do the same for second scenario. And now we are able to measure the distance to traffic sign, which is around 80 meters for the first scenario and about 150-160 meters for second scenario. And third scenario is not actually third, it's first scenario, but car was at a bigger distance from traffic sign. It was at approximately 110-115 meters from the sign. We could see it by drawing a line from a sign and through this light pole. And finally, the height of sign and letters and sign orientation. We actually do the same that we did before to identify car positions. It's GMC Terrain 2016 year of manufacturing. And as far as these two objects, the car and the sign, are at the same distance from us, knowing the height of this car, we can calculate the height of sign with post, sign itself, and as a result, the height of letters. Letter J is 8 inches, all other letters are 6 inches. Now, after we've got all distances, dimensions, relative positions, we can calculate the angles. On this stage, that would be more complicated for you to check my calculations because you'd have to understand basics of vector algebra and be familiar with principles of retroreflection measurement. If you have any questions, leave them in comments. As you see, there is only one conditionally relevant rod scenario. Why? Because in second scenario, you are looking at a sign that you shouldn't be seeing at all. This sign is informing drivers coming from another direction. In addition to that, you would need binoculars to see this sign from this distance. All of you have to be familiar with Snellen chart. People who can read this line are considered as people with normal acuity. To read the sign in second scenario, you have to be able to read the line below and at entrance angle of 45 degrees and from moving vehicle. Try it. And why do I call first scenario conditionally relevant? Because position and orientation of sign, letters, height tell us that expected reading distance for this sign is much shorter than the one proposed in first scenario. We're getting back to video.
We fabricated a sign using two different ASTM D4956 Type 11 sheeting materials. On the left, 3M diamond gray DG cubed sheeting copy was fabricated at 0 and 90 degrees orientation.
Now we know that's lie. There was no reason to use specific orientation. In both rod scenarios, entrance angle is not 50 degrees or wider.
On the right, competitive Type 11 reflective sheeting was cut at multiple orientations per their sign fabricator recommendations.
Now today is June 2020 and the only Type 11 retroreflective sheeting that has no limitations from manufacturer on orientation is Avery Dennison 11500 OmniCube. Let's download the product bulletin and find out what's in there. Product bulletin is dated February 2017. In sheeting orientation section, there's no recommendations at all, but 3M lies again. Listen carefully to voiceover.
On the right, competitive Type 11 reflective sheeting was cut at multiple orientations per their sign fabricator recommendations.
Was cut multiple orientations per their sign fabricator recommendations. It's a pure lie. There is no recommendation in Avery Dennison product bulletin to use multiple orientations. It's not even manipulation, it's pure lie. Now 3M 4090 DigiCube and Avery Dennison 11500 OmniCube both utilize so-called full cube prisms. Those prisms look like this. These prisms are even more sensitive to its orientation. Look at a chart where corner cube and full cube materials are compared. On top, it's a prismatic material that utilizes traditional corner cube prisms, and at the bottom it's DigiCube by 3M. At narrow entrance angles, DigiCube is better than traditional corner cube prism. However, starting from 20 and even 15 degrees entrance angle, the retroreflection getting lower and lower, and for 40 degrees, for example, entrance angle, angle, the retroreflection of DigiCube is way lower than retroreflection of traditional cube corner prisms. You can do these measurements yourself. No need to trust only my measurements. All the angles here are specified. It's really easy to check. 3M DigiCube has two orientations of prisms, 0 degrees and 180 degrees. And Avery Dennison 11500 OmniCube sheeting has 4 prisms orientations, 0, 90, 180, 270 degrees. Take a look at this board. At the right, you see 3M DigiCube pieces with 0 and 90 degrees orientation. At the left, you see Avery Dennison OmniCube retroreflective sheeting pieces with 0 and 90 degrees orientation. The one strap in the middle is created from squares of 45 and minus 45 degrees orientation of Avery Dennison sheeting. While entrance angle is narrow, you don't see a big difference in appearance, but if I make it wider, you see how orientation affects visibility, and you should see that Avery Dennison squares with 0 and 90 degrees orientation, they appear the same, while 3M appear different. I can also show you the diagrams explaining this effect in numbers. We can clearly see that no matter if it's 0 or 90 degrees orientation for OmniCube Avery Dennison, you will get the same performance. For 3M, you will see the difference between 0 degrees and 90 degrees orientation of sheeting at angles wider than 15 degrees. Design and cut job. How normal adequate designer would cut this image. Standard width of microprismatic roll is 48 inches or 1.22 meters. I prefer to work with 0 and 90 degrees orientation because of simple logic. Almost all letters of alphabet, especially capital letters, perfectly fit in a rectangle, right? And if you want multiple rectangles of different sizes and side ratios to occupy minimal area, you will never use orientations other than 0 and 90 degrees. However, there are exceptions like arrows, special symbols, borders, that you will probably use different orientations for during sign design. Don't forget that you pay not only for waste, but also for time of designer. So there should always be a compromise between time designer spends on optimizing a cut job and getting lower rate of waste and benefits from the lower rate of waste. Usually you have more than one sign to manufacture, of course, but in those exceptional cases where you would need to manufacture only this particular sign, you would have following options. Position all elements at 0 degrees orientation and occupy 1.37 square meters. Position all elements at 0 and 90 degrees orientation and occupied 0.56 square meters. That would save almost 60% of sheeting cost. Or position all elements at 0 and 90 and 55 degrees for the arrow orientation angle and occupy 0.53 square meters, which is 5-6% cost reduction comparing to 0 and 90 degrees orientation. With normal workflow, where you manufacture several or many traffic signs at once, you will get lower saving on waste, but you will still see the difference.
It was then mounted at an actual roundabout. A mid-size SUV traveled through the roundabout.
Its lie, in reality scenario would look like this.
With cameras positioned to give a driver's eye view.
3M said that they give driver's eye view. Drivers don't have zoom function in their eye. There's no zoom in human eye, only focusing and changing aperture size, no zoom. So 3M is giving eyes view of driver with binoculars attached to his head, probably,
to capture the difference in reflective performance when illuminated only by the vehicle headlights. In multiple driving scenarios, the application method affects visibility and performance.
Lie, we already know that there's only one conditionally relevant road scenario here, binoculars attached. I actually doubt whether 3M used Avery Dennison sheeting for these videos at all. That would be just a waste of corporate resources. They could use the same 4090 DigiCube sheeting with 45 degrees orientation and we would see the same appearance. Now, second scenario would look like this.
We believe signs that are uniform in appearance best convey messages to drivers.
Now, among multiple lie, there should be something undisputable. Like signs uniform in appearance best convey messages to drivers. With the same effect, any similar statement could be used, like driver's safety is important, for example.
Others would have you believe this can be achieved by making compromises in the sign fabrication process, but we've chosen to follow a different path.
Yes, you've chosen to show a zoomed image of sign located at 115 meters distance and manufactured based on false statements. And that's it for today. Again, I think you're smart enough to make your own conclusions on microprismatic technology, on rotationally sensitive, insensitive materials, about two manufacturers, about other things we've discussed today. If you have any questions, put them in comments. And I hope that now you know who to contact for a smarter approach to road safety. Be safe on the road, guys. Bye-bye.